So I'm guessing that you already know what are charges.
Yeah.
And what exactly are those?
Plus Q and minus Q.
Correct. Plus Q and minus Q. And in general, if we have to say, what we need to remember is that whenever we talk about moving charges or static charges, we are going to be talking about this branch of physics, electrostatics. Okay. This will be dealing with stationary charges also and moving electric charges also. Now, like you said, charges are of two types, plus Q and minus Q, positive charge and a negative charge. And you must have also studied gravitational law, right?
Yeah.
You must have studied that if there are two objects, they will always be exerting a force of attraction on each other, which was called as the force of gravity. You remember this?
Yeah.
So it's similar to what we are going to see right now. We're going to talk about Coulomb's law of electrostatics. So when we say that we have these two charges, plus Q and minus Q, they always are exerting forces on each other. Okay, and what kinds of forces do they exert on each other? The positive and positive charge. Will it be an attractive force or a repulsive force?
It'll be a repulsive force.
Correct. You're right. It will be a repulsive force. So basically, whenever you have two similar charges, positive, positive, negative, negative, they will be repelling each other. And whenever you have unlike charges, they will be attracting each other. And that is what we will remember. That is one thing which is different from gravitational law. In gravitational law, you must have read that, it's always an attractive force. Right? There is no repulsive force because in masses, there is nothing like positive or negative. But in electrostatics, what happens because we have a positive and a negative charge, if there are two positive charges, the force will always be a repulsive force on them. Suppose if this same diagram, if I was to make like this, and this is still Q1 and this is still Q2, then what would happen here is that this force would have been an attractive force. Correct?
Yeah.
Okay. Now see, when we talk of forces, we also need to understand what are the factors this force must be depending upon. So of course, this force will be depending upon the amount of charge, and it will also depend upon the distance where these charges have been kept. Okay. So this is the relation which I'm guessing you have already learned. And from here, what do we have is that force is directly proportional to the product of charges, but it is inversely proportional to the square of distance, correct?
Yeah.
Okay. Now, of course, whenever we are going to talk about these proportionality signs, there's going to come a constant. But this constant has a significance. Do you know what's that significance? I mean, what's the importance of this constant K? Any idea? No. Okay. Do you know what's permittivity of free space? Has it been mentioned to you?
Yeah, it means like the allowing a material to resist permittivity.
Correct. Absolutely. So see, when we say that there are these field, or you can say that there is a force which is existing here. What's also important is how much of that force or how much of that field is this medium going to allow. Okay, because these charges are kept in some medium. Now, of course, that medium will be different, and accordingly, this value also will change, which you will later study in this class. that what if, you know, these charges, like right now it's a free space, but what if I keep something in between? So of course, this K value will change in that case. But as of now, what you need to remember is that this K value has a fixed value of 9 in, actually it is 8.99, but then that can be rounded off and written as 9 into 10 to the power 9 Newton meter square per Coulomb square. Okay, the value of this K. Okay.
Yeah.
So this is about the Coulomb's law, which we've talked about. Now let me ask you a question. Let's see if suppose that there were these two charges Q1 and Q2, and they were at a distance of, let's say, r apart, and the force of Coulomb was, let's say, for F. What if I double the two charges? If I will double both the charges, what will happen to the force?
It'll be 4q1 q2 by r square.
Correct. So can I say that it will become 4 times what it was before I doubled the charges?
Yeah.
Now tell me what will happen to it if I make the distance double. I'm leaving the charges as it is, Q1 and Q2. I'm not doubling them, but I'm doubling the distance between them. Then what will happen?
It'll be the force will be doubled.
Okay. Think about it once again. I'm doubling the distance between them. Okay. That means instead of R, now the distance will be,
4 times.
sorry,
It'll be 4 times.
it will be 4 times, you're saying.
Yeah.
Will it be 4 times or 1 by 4 times?
1 by 4 times.
You understood the difference.
Yeah.
Okay. Because R is in the denominator. Okay.
Yeah.
So that's why we say that force is directly proportional to the charges, but it is inversely proportional to the square of distance. Okay. Now, suppose if I do both of these things, I am doubling the charges also and I'm making the distance also double. Then what will happen?
Then it'll be the same.
Correct. Absolutely. Very good. So in that case, it will become the same because in this case, it was increasing by 4 times. And in this case, it was getting reduced by 4 times. That 4 and 4 will cancel each other. So that's how the force varies if the value of charge or if the distance between those two charges, if they will be changing. Okay. Now, of course, this is something that we've already seen, that Coulomb's law is actually, it's a repulsive force when we talk of similar charges, I mean positive, positive or negative, negative. And it's an attractive force when these two are opposite charges. Okay.
Yeah.
So, okay, now because in physics, it's also important that you understand that all of these things that we are talking about are all vector quantities. I mean force. Okay, whenever we talk of force, you must have seen that we always put an arrow on top, right?